Is it big? So the discriminant is the part of the quadratic formula that's underneath the square root. The discriminant is just this part. No square root though, just the b squared minus 4ac part. And that's what it says here. The discriminant of a quadratic equation is the b squared minus 4ac. What that will tell you is how many solutions you have and what type of solutions that you will have. Okay, so quadratic equations can either have one or two solutions. They would have one solution if the answer came out to be the same, like x equals 5 and x equals 5. And the graph of that would look like this. It would come down, touch 5, and then turn right around and go back up. So it really touches the x-axis and then changes direction. Obviously, if we have two solutions, that's what we're used to seeing. It would have two intercepts. It also could have two imaginary solutions, which we know would have our I in it, like 2 plus or minus 3i. So you can determine the number of solutions and the type of solutions by finding this value, your discriminant. So we're either going to have two real solutions, one real solution, or two imaginary solutions. Okay, so the value of the discriminant, if the discriminant, b squared minus 4ac, is greater than 0, meaning that it's a positive number, or positive value, then you are going to have two real solutions. Okay? Two real solutions could be like x equals 2 and x equals 6. Or real solutions can have square roots, so it could be like 2 plus or minus the square root of 10. Okay, those would be examples of two real solutions. And the graph of those would actually go through at two distinct spots. So the questions that we'll see will say, determine the type and number of solutions. Instead of actually finding what the solutions are, we're going to use the discriminant to describe how many we'll have and the type. Abby?
Because how you're saying they're like positive values, it can still go in the negative, like you still have a solution that's negative.
Yes, this, I'm saying the discriminant is positive. Okay. So that's not really your answer, it's just telling you how many answers you're going to have and what type. This is just showing what the actual whole function would look like, not just the discriminant part of it. Good question. Now if the discriminant value, the b squared minus 4ac, actually equals 0, perfectly 0, then you're only going to have one real solution. And that was, there's one on the homework where it was just x equals 5, because we ended up getting 5 and 5. Again, that graph of that function will just come down and touch at one specific part and then turn around. Or it could be a downward facing parabola that comes up and just has one x-intercept. And then the last part says if the discriminant is less than 0, so if it's a negative number, this will have no real solutions. It will have two imaginary solutions. And those answers, which again, we're not going to find the actual answer. We're just going to describe how many solutions we're going to get and what type. But an example would be like 2 plus or minus 3i. That's an example of two imaginary solutions. The graphs of these functions look like they have no x-intercepts because they have no real solutions. So these ones are the type that actually cannot be done on the graphing calculator even if you wanted to, because it would not be able to find the 0. All right, so the questions at the bottom, again, do not say solve. So we're not using the quadratic formula to get two answers. We're just asked to determine the type and number of solutions that each equation has. So all we have to do for this one is to use the discriminant. So we're going to do just the b squared minus 4ac portion of the formula. Again, this is not going to tell us what the answers are. It's just going to tell us how many answers we would get and what type they are. So we can see that A is 1, B is 5, and C is 10. So we just plug in those values. Again, use your order of operations, so exponents first. And then you are multiplying all three of those things together. So -4 times 1 is -4 times 10 is -40. And then we would subtract those and we will get a negative number, -15. Okay, so since the discriminant is negative, that indicates that there are no real solutions, there are two imaginary solutions. So that's our final answer, because they just want to know the number and type of solution. So it's either 1 or 2, and it's either real or imaginary, depending on. Awesome.
To check it, would you be able to just do the quadratic formula?
Yes. So if you wanted to check it, you could do the whole quadratic formula and realize that your two answers are going to have an I in it. Yep. Next one, we'll do the same thing. A is 1, B is 6, C is 9. You do want to make sure it's in standard form, so set equal to 0 before you identify A, B, and C. Find your discriminant. You also could check this on the graphing calculator too, Austin. So if you were to type this in your y equals and press the graph button, since it has two imaginary solutions, the graph should look something like this, where it's never crossing the x-axis, and that would indicate that it doesn't have any real solutions too. That would probably be a faster method than doing the whole quadratic formula. This one we should get 36 minus 36, which is 0. Again, 0 is not the answer, it is just the value of the discriminant, which tells us that there's one real solution. Go ahead and try example 3 on your own. All right, what do we get? 2 real, 1 real, or 2 imaginary solutions? Eric?
Imaginary.
Good, we should be getting 2 imaginaries. And that was a -4, so any negative number gets us 2 imaginary solutions. Perfect. All right, on the back we have some word problems. You can use the discriminant to solve these word problems, but sometimes with the word problems, especially after we take our chapter 5 test next week, we'll be doing a performance task. It's usually easier to actually think about the problem like we did before, where we were kind of sketch a little picture and think about what things represent, like the vertex and the x-intercepts in regards to the problem. So that's how I'm going to teach it instead of showing you with the discriminant, because most of you after this lesson won't think about the discriminant in terms of this problem, and it only works to answer one part of the question. So it says a player throws a ball up and towards a wall that is 17 feet high. The height h in feet of the ball after t seconds after it leaves the player's hand is modeled by this equation. So first of all, this equation, we can see that the a value is negative, which does indicate that we're going to have a negative parabola. If the ball makes it to where the wall is, will it go over the wall or will it hit the wall? Okay, so you want to think about this picture. So this is our height, and that's in feet. And this is our time, which is in seconds. And so we have this little parabola again. I'm just kind of sketching it. Okay, the wall is 17 feet tall. I'm actually not going to draw the wall in because I don't know if it's going to be taller than this point or if it's going to be shorter than this point, but it's somewhere along there. So thinking about the problem, I want to know if it's going to hit the wall or if it's actually going to go over the wall. Well, if it goes over the wall, it has to be going higher than 17 feet, right? How do I find out what the maximum height that the ball will ever reach would be? How do I find out what the maximum height is? Say again?
The equation.
The B equation? What's that? What's that point called? Okay, so we need to find the vertex. And then I think you were saying what the vertex formula is. It does have B in it. What is the formula for the vertex? Ashley? Good. This is a good little review because we're going to be reviewing chapter 5 here tomorrow on Monday. So remember, it's always come up blank because you have to plug that number back in to find out what the y value is. So we see this is our A, our B, and our C. So we'll plug in those values. We'll have negative 25 over 2 times negative 16, which will get me negative 25.
Mrs. Garda, please dial extension 6505. Mrs. Garda, 6505.
32. The negatives are going to cancel, so 25 divided by 32 gets me this number. You do not want to round this number. Okay. So you might want to type that in your calculator so that you have it. I'm going to show you a nice way that you can input this without having to do a lot of button pressing. So just in your calculator, you could even type in negative 25 divided by negative 32 if you want, but you just want to have this answer sitting as your last answer. And I'm going to show you something else our graphing calculator can do for us. So normally we'd have to take and plug that number in each of these values. So we'd have to type out that number, 2 times and then have squares and parentheses, etc. So if you have the answer right here, you can actually store this value for a variable. So if you notice, there's an STO key, which stands for store. If you press store and then press the X button, or XT theta, and hit enter, it will actually plug that number in for X. So now, if you want to evaluate this, you can type in negative 16x squared plus 25x plus 6. And what it's going to do for us is it's going to take that number and store it for x. This is super useful, especially if the decimal ended up being like significantly longer, so you wouldn't have to type out everything and or round it and get a wrong answer, and then press enter and it will find it for you. Okay, now you could get this same thing by typing this in for t everywhere, but this is significantly faster. Okay, so that's going to give me my y value, which is 15.76. You could round this number because it doesn't really matter. 5625. So that's our maximum height. It's the highest the ball's ever going to reach. So is it going to be able to go over a 17-foot wall? No, because it's never going to go higher than this. So it's not as high as 17 feet, so it's going to hit the wall. Okay, you're going to throw it up, and eventually it's going to hit the wall, either going up or coming down at some point, but it's not going to clear the wall. Now, just as because when we do these performance tasks, remember also sometimes they'll ask you how long was the ball in the air? Just as an extension question. How would I find out how long the ball was in the air? Abby?
Plug in the 15.76 in for the H and solve for the variable T.
Well, we actually have that. We actually already have that, so you don't need to do it again. Jade? Yes, that will work. We know that this would be 0.78125 distance. This would also be 0.78125. So you can double them or add them together to get the total time. There's another way to do it too. Aren't these called the zeros? The x-intercepts? So another way you could do it, which since we already did this, I think Jade's answer is the best because we already had that number, we just have to double it. But you could also technically set this equal to 0. When the height is 0, what are the values? And you could solve using quadratic formula, graphing calculator, factoring possibly, if you wanted to try it. But those are some of the questions you'll see in the performance task. We're doing the Angry Birds. If you have friends in Mr. Riener's class, they already did it, but you'll be doing it now. He just did it earlier because he was going to be absent and they needed something to do all this time. So their test will be later in the week than ours next week, but we'll be doing a different version of it. I think I have 5 different versions, but same type of activity. All right, see if you guys can read through number 5, come up with a plan, maybe sketch a picture, and then we'll go over that one.